Assalamu alaikum. This is the second part of Introduction to Vectors. And we said that we need trigonometry again. I want you please to go and study this lesson again. Each day, please study at least 10 minutes because we will use this, please. Okay, so again, we will continue identify vector quantities and we will represent and operate with vectors geometrically during this lesson. Okay, so last time we had the vocabularies. We took what's the meaning of vector, initial point, terminal, standard, direction, and magnitude. Now we said that the vector should contain direction and magnitude. The magnitude is the length of the vector. Today, inshallah, we will take the meaning of quadrant, bearing, and true bearing. This is our lesson. Before that, who solved the homework? I gave you homework. Who solved it? Good, excellent. Let's start. Define a scalar and a vector quantity. We said the difference between a scalar and a vector is the direction only. Which one contains the direction, scalar or vector? Excellent. Here we have magnitude plus direction. But in a scalar, we have only magnitude. Who solved this? Excellent. Now, question number 2. Which is a scalar and which is a vector? I told you yesterday, just please look at the keywords of the question. The first one here, we have a 20. So this is the magnitude. Seconds of time, this is the unit. This is not a direction, so this is a scalar. A mass of 10 kg, again a scalar, we have no direction. The length of your pencil, any pencil, it has a length, but no direction. Instructions of treasure map. Okay, this is fun now. Treasure, usually, they will tell you to go left, right, east, west, north, south, with how many meters, how many kilometers you have to move. This means we have a directions here, so this is a vector. The force of friction, this you took it in physics. I will write it for you, vector, and I want you to go back to your physics teacher to ask her about that. Your age, of course, it's a number. We don't have direction, so it's a scalar. 5 miles per second or 5 meters per second west. West, this means we have a vector. A weight of 15 Newton, there is no scalar. There is no direction, sorry, so it's a scalar. Now, in a vector, the length of the arrow, what do we call the length yesterday, if you remember? Is it the magnitude or direction? Excellent. It's the magnitude. Next time, I want you to tell me how much did you take out of 10? If you solve it, please, I want to know how much did you take. Okay. Now let's start with our lesson, bearing. The true bearing to a point is the angle measured in degrees in a clockwise direction from the north. This is the definition. Let's explain it. The key word here, we have a north. We will start from the north. It's an angle, but we will start from the north. This means that the vector starts moving from north clockwise. This is a clockwise until we find our angle, which is 65 degrees. We write it like O 65 degree. This means we have a true bearing here. This means again that the vector starting should start from north, not from anybody else. Okay, so can you tell me what do we call this? Let's see. This angle, we're starting from north clockwise until we reach the terminal. What do we call this? Yes, excellent. Oh, 300 degree. This is again true bearing. So you have to combine true bearing with north. Again, start with north clockwise. The second one. The direction can also expressed as quadrant bearing. Okay, this is the explanation. If you want to read it, I will explain it for you here. Please look at this word. N 23 degree west. We read it 23 degree west of north. West of north. In some books you will find it like 23 degree west of north, or N alone, okay? So what does this mean? This means I will start from north, going in the direction of west with the 23 degree. Please look carefully. I will start with north, going to west. Where is west? This is west, right? So from north till west with the protractor, you have to find the angle 23. This means I will put the protractor here, and the angle here should be 23 degrees. So north until you reach, or you go in the direction of west. We read this 23 degree west of north. Again, west of north. We are starting from north going to the west. Let's try another angle. For example, if you have a 20 degree E here and north here. What does this mean? We are going 20 degree east of north. Where you have to start from? Excellent. I have to start from north. Another color. Let's start. So I will start from north going to east. This is starting from north going to east. And what is the angle should be? Excellent. 20 degree. Again, we read it 20 east of north. I'm starting from north going to the east. This is my vector now. I hope it's clear. Okay. So the common way of identifying direction is by referring to east, north, west, and south. This is just, let's say, practicing for you. Let's start with the first one. Let me change the color. Yellow will be okay. Okay. What's this? Excellent. This is the magnitude. And what's this? The direction. We read it north of east. From where I have to start? From east. So I will start to east going to the north with 50 degrees. This is my angle. Again, this is my angle. I want you at home to try to practice these three. If you need any question, let me know next time. So this is just practicing for you. Okay. Another question. Use a ruler and protractor to draw an arrow diagram for V equal 10 newtons. Okay, let's put a line here. Changing the color. Okay. This is, what do we call this 10 newtons? Yes, it's the magnitude. What do we call this? It's an angle. Horizontal, what does it mean? Horizontal. Excellent. This means we are going from the origin horizontally to the east. This is so important. When you see the word horizontal, start from origin to east. I mean on the x-axis. On the x-axis, okay. Type. If I have 10 newtons, suppose I have 30 or 40, can I represent them here all? It's a big number, a huge number, right? Let's do it in a scale. Scale means, instead of writing 10 newtons, I will represent each 1 centimeter, for example, with, let's say, 5 newtons. This is optional. Yani you can choose whatever the scale you want. For me, I will use 1 centimeter. For each 1 centimeter, 5 newtons. If I have 10 newtons, how many centimeters should we have? Excellent, 2. What did we do? 10 divided by 5. So 10 divided by 5, 2. This means the length of my vector should equal 2 centimeters. So it will be easy for us to represent it here on this graph, on this coordinate plane. Instead of drawing 10 centimeters, I'll draw 2 centimeters. Now, horizontal again means on the x-axis starting from the origin. Put a ruler. This is my vector with 2 centimeters. Yani you should put a ruler here and find the magnitude here, find the distance. It should be 2 centimeters. I hope it's easy. Again, we will start in standard position. This means I'll start from the origin, and when we finish, please just put arrow. This is the initial, this is the terminal. How is that? It's easy, right? Can you try this? I'll give you 1 minute. We have z equal 25 meters per second, 70 degree west of south. Okay, did you finish? Excellent. Let's start. Now Z25. 25, it's a big number. I can't represent it here in this small graph. So I need to put a scale. The scale here, he chose for us 1 centimeter for each 10 meters of second per second. This is up to you. If you want to use more, it's up. Less, it's up to you. Okay, this means if I have each 1 centimeter equal 10, and I have a 25, how many centimeters should I have? Divide 25 by 10, the answer will be 2.5. This means that the length of my vector should equal 2.5. Now let's graph it here. Okay, he said west of south. Do you remember? West of south means I have to start from south, this is south, going to the west. What is the angle? 70. So I will go here with the protractor. This should equal 70 degree. Now, what is the length of this vector? Put a ruler on this vector, and it should be equal to 2.5 centimeter. I hope it's easy now. Let's start with another example. You have 1 minute to try to solve it. The first one will take +1. Okay, did you finish? Good. So we have 10 miles. We want to represent each 10 miles with 1 centimeter. It's up to you. Okay. So, and the angle is 25 degree from the north, clockwise. Clockwise means in this direction, from the north. He explained it for us, from the north. And he write it as a notation. Do you remember this notation, O 25 degree? Okay, so starting from north, the angle should equal here 25 degree. What is the length of this vector, the magnitude? 1 centimeter on the graph. What is the length of this magnitude of this, this vector in real life? Is it 1 centimeter? No, of course, it's 10 miles. Be careful. In the graph, it's 1 centimeter. On the real life, it's 10 miles. I hope it's easy. Okay, this is your question. We have n equal 20 feet. Of course, I can't represent 20 feet. It's up to you which one you want to choose. But since we have choices, you have to stick with the choices. And we have the angle O 80 degree. O 80 means we are starting from north, clockwise. I guess we have only one angle. We're starting from north regarding the magnitude. So this is my answer. I hope it's easy. And these are exercises you need to solve at home. I'll see you next time. And please, if you need any question, let me know. Thank you.